So the first group discussion, we didn't discuss sample facts or results. So the first question, why the sample variance is an unbiased estimator? In fact, I already have some hints to derive further. But this time, I ask you this question, why? That says anyone can extend further to have the result to reach sample variance is indeed an unbiased estimator. So understand the first question. And the second question. The second question, explanation of sample variance under covariant stationary process holds. I mean, some formula still holds. For this one, later I will show you the problem in the pole everywhere. All right, so the two. And this time I try to assign group 1 and 3. Think about, actually think about this one. Problem 1. And group 2 and 4. Think about problem 2. Is it okay? Of course, for this group, if possible, I try to directly have the discussion later. And for the discussion, I directly have this time, maybe 8 minutes. So we have a good discussion for sure. So right now, you can log in. All of you should have the answer later after discussion. And the problem re-study in the pole article. Previously, I just let you know the simple description. For the detailed description, you should scan the QR code. I saw that you have the problems. And right now, it should be 10:26. I already have 8 minutes to have the discussion. Okay, go and check it. And if possible, you can write something on your own screen or your file. You can write on A4 page, and so that you can scan. I mean, later if you want to show, you can scan. And any group needs to have the pages. So for group 1 and 2, of course, you should stay for problem 1, right? And for group 2 and 4, you will key in skipped, SKIPPED, and then you can see problem 2. So problem 1, actually we already have a sample variance, but why? This sample variance is an unbiased sample variance. Sorry, unbiased estimator. So the second problem, actually, it will have a detailed one, so you need to check the problem on pole everywhere, right? So let me check, Kevin. Can you see the problem on pole everywhere? Okay. And Evans? Oh, Alice? See the problem on pole everywhere? Okay, thank you. Actually, time almost up, but let me have, there you have 1 more minute.
find this different because I find the source code or check the what's code.
但是出来只是可能就是数字。
对，出来，但是因为它目前相信数字。
You can speak louder, sure.
Okay. Okay, everyone. Our question was why the sample variance is an unbiased estimator of given IID observations.
Yeah.
And I will try to explain why.
So this is the answer provided by your team, right?
Yeah.
Your group.
Yeah. So that's our answer. We will try to derive answer from formulas. So let's say we have a sample variance with S square, and we have an unbiased estimator of the population variance. We know that sample variance formula is the one that you can see in the screen, and where x with this line.
So at this moment like this, you let us know sample variance here, and try to derive so that we can get the expected value.
Yeah.
Maybe set it to mute.
Okay.
Because of the echo, so that's why.
And the main point is that if you
Set to mute for all. Mute.
No, it's not muted.
Because of echo, so that's why. So all of you set it to mute. Unless good one. Oh, sorry, good one also mute. And I'm not mute, sorry. Alright, so you can continue.
Okay. So the main point is that if you want to prove that sample variance is unbiased estimator of IID observation, we need to prove that sample variance is
Expected value of sample variance.
values of sample variance is equals to
Sigma square.
sigma square. Yeah.
So that's your opinion, right?
Yeah.
But how to achieve it?
Yeah, we will derive.
So derive it already?
Yeah. Can you show the second image? Yeah.
So this is a way to derive.
Yeah.
So can you check important steps?
So you can see the derivation on your screen, and after that we can say that an expected value of sample variance is equals to.
So here, in fact, think about this: SI minus sample mean. Sample mean is not equal to true mean, mu. So this step to this one, maybe something wrong. Right? So you say this, of course, finally you have this, of course, not equal to sigma squared. So something wrong, but yes, we need to start from this, how to have a sigma squared rather than this value. That's it. At least you let us know some troubles if we want to have the further derivation. If you jump from the step to this one, equal to variance of S sub I, no, something wrong. But that's okay, so this is the possible sharing from group 1, right? Well, maybe it doesn't mean you want for the solutions, but at least I have the solutions. This is the first one. Well, minus mu, but minus mu. Why? Because minus minus we have a plus. So that's correct. But however, try to be patient. Try to be patient, then we can have other result. Found is true, sigma squared. At least take a picture first. I will that you have the reference solutions, for sure. So can you take a picture first? I will release the solution later. So this is the first one. Maybe for all of you check it first. Next week bring your questions or problem to me. And next one. And not completed, so we have the second half. So take a picture again. I will release it later, so you can check it in advance. And next week, if any questions, we can check it quickly. Because maybe it's really important, but I do not emphasize to check all the details. At least know how to reach it and get something possibly to go into the derivations.